Alright, here's a short video on cube roots, and it kind of applies to any root that you want to do. And the first thing you always have to notice is we notice the root symbol, okay, on both of them. And the next thing you need to notice is what the index is. Now you'll see that on the left one here, the root of 8, there is nothing on top of the radical symbol, but on the one on the right, there is a number right there. Now these things are called the index, and the index is kind of your second clue of what you're doing. The first clue is that you get this radical symbol, and your second clue is what's my index, because they have different, depending on what your index is, it's a different question. So for example, this one is saying what is multiplied times itself 3 times. The one on the left is saying what is multiplied times itself 2 times. And we don't usually write the index when it's a 2, and that's why the symbol is called the square root very frequently. But it's really the radical symbol with an index. On the left side here, this is a square root. On the right hand side, this is a cube root. So we have to pay attention to that. Okay, so let's look at the square root of 8. What we're looking for is what is multiplied times itself 2 times. So I'm going to factor 8. It's 2 times 2 times 2. And if I look inside this square root, I see that 2 is multiplied times itself twice. So a 2 gets to come out to answer the question. And the radical 2 means there is some number, I don't know what it is, about 1.14 I think, that if you multiply times itself, you will get a 2, but we don't want to leave it or get those decimal values. Yeah, 1.41 is what the square root of 2 is, but that's an approximation. Okay. On the right hand side, we want the cube root of 8. Okay, so I'm going to factor the 8 again. And this time the question is, what is multiplied times itself 3 times? So the answer clearly is 2. So that's just equal to a 2. Now the way we do this, as we get more difficult problems, is we look for what we call perfect squares. Or we look for things that are perfect cubes. And what you'll notice, I'm going to put a little 2 up there on the square root symbol, when these match, the answer is whatever the base is. So there's the 2 that's squared, and I'm left with the 2 inside. Here I want to know what's cubed, and the answer is 2. So if we can get those exponents and indexes to match, then we know what the answer is. Alright, so kind of use that as a strategy as you're trying to solve these problems. So here's a few examples. Let's look at the cube root of 8 here first. That's the cube root of, and I'm going to factor that 8. Now, negatives can pose a problem for us. The thing I want you to realize about a negative number is that you can just think of it as a -1 times -1 times -1, or as many negative ones as you need, as long as it's an odd number. Okay? So right away, when we see the cube root of a -8, I would think of that negative as being 3 negative ones multiplied together, or a -1 cubed, and so a -1 comes out. And so it's now just what's the cube root of 8? We've just seen that that's a 2, so it's -1 times 2, or -2. Okay? Now certainly, depending on how you think of things, oops, erased a little bit too much there. Depending on how you think of things, you can think of the -8 as -2 cubed. Now we match, so the answer is -2. So look at the cube root of 64. 64 is a 4 times 4 times 4, or a 4 cubed, and so the answer is just 4. See that negative sign on number 223? Right away I'm going to pull out a negative. I'm cube rooting it, so I know it's 3 -1s multiplied together. The 27 I'm going to think of as a 3 cubed. See that match? The x to the 6th I'm going to think of as an x squared cubed. That still equals x to the 6th right there. But now that I've written it as something cubed, I get that match. And so I've got a negative on the outside. This 3 gets to come out, and this x squared gets to come out. And the very last one is a cube root in a positive number, so I don't have to bring out a negative sign. 125 is 5 cubed. A is cubed. And b to the 12th, I'm going to write as a b to the 4th cubed. Look at how everything matches there. And so what is taken times itself 3 times? A 5 is, an a is, and a b to the 4th is. And I've simplified that radical, or that cube root. So we've got a few more of these to do. I'm going to put in, this is actually your homework page I'm putting in, but I'm doing the classwork problems. Let's get rid of some of the stuff. There we go. Let's look at this first fraction. It's a cube root, so we want things written as cubes. I've got a negative, so a negative can pop out because that's a cube root of negative 1, negative 1, negative 1. And x to the 18th I'm going to write as x to the 6th cubed, and I'll write that 1 as a 1 cubed. 1 cubed is the same as 1. But now I have matching exponents and index. Matching exponents and index. And so I get a negative on the outside, a 1 in the numerator, x to the 6th in the denominator, and that's the same as this answer, the negative on top. 226 I would think of as a c to the 5th cubed, or a d to the 8th cubed, matching exponents and index, so I get c to the 5th over d to the 8th. Cube root of 1, that's a 1, 1, 1, so 1. And I don't know what multiplied 3 times together gives me 216, but I know 3 negative 1s multiplied give me negative. So now I would factor this guy. So I'll go 2 times 108. I'm looking for 3 of a kind here. 2 times 54. So now I've got 2 and a 2. 54 I'll do is 9 times 6. I'm going to get this thing all the way factored till I find 3 of a kind, because that's the question. So 9 is 3 times 3, and 6 is 2 times 3. So if you look at everything I have, look at these 2's, I got 3 of them. So I can rewrite that as a 2 cubed. And look at the 3 3's. That's a 3 cubed. And so index and exponents match. So a 2 comes out and a 3 comes out. I already brought out a negative, so I've got negative 2 came out and 3 came out. It's all multiplied, so negative 6. Hopefully that will help you understand how to do cube roots.